Far above the night side of Earth, space begins just beyond the thin blue line of air that holds in the weather and the wind. The boundary often used is called the Kármán line, placed at roughly 100 kilometers above sea level, though the atmosphere fades gradually rather than ending all at once. At this height, the sky is already a deep black, and the curve of Earth fills most of the view. Astronauts in low Earth orbit circle the planet roughly every 90 minutes, gliding at about 7.7 kilometers per second. From that vantage point, a sunrise or sunset arrives about every 45 minutes, painting the atmosphere in slow bands of red and violet. Below, lightning pulses in quiet flashes, and city lights form delicate webs. Above, stars no longer twinkle, because there is almost no air to blur their light. This is the first step away from home, a thin shell of orbit where human spacecraft and stations drift in a continuous fall around the planet. Beyond this shell of orbit, the familiar Moon moves silently around Earth. Its average distance is roughly 384,000 kilometers, so far that all of Earth's continents could line up edge to edge between the two. Light from the Moon takes a little over 1 second to reach human eyes. The near side, the one always turned toward Earth, shows darker patches of ancient lava called maria and lighter highlands covered in craters. Temperatures on the surface can swing from roughly plus 120 degrees Celsius in sunlight to about minus 170 degrees in shadow. The Moon's gravity lifts Earth's oceans into tides, very slightly slowing our planet's rotation over long stretches of time. As a result, the length of a day grows by a tiny fraction of a second every century. The Moon is slowly drifting away as well, at roughly 3 to 4 centimeters per year, a pace similar to the rate at which fingernails grow. Millennia from now, eclipses will look subtly different from those seen today. All of this plays out under the light of the Sun, an ordinary star of the type called G-class, roughly 1.4 million kilometers across. Its light reaches Earth in about 8 minutes, crossing 150 million kilometers of mostly empty space. The bright rays that warm the planet are only a tiny fraction of the Sun's total output. It also sends a steady stream of charged particles, called the solar wind, flowing outward in all directions. When these particles encounter Earth's magnetic field, they are guided toward the polar regions. There, they collide with atoms of oxygen and nitrogen high in the atmosphere, producing curtains of green, red, and violet light called auroras. The Sun rotates, but at different speeds depending on latitude, taking roughly 25 days at its equator and longer near its poles. Under its surface, sound waves ripple and reflect, allowing scientists to study its interior using techniques similar to listening for echoes in a large, resonant hall. Orbiting this star are the planets, each carrying its own quiet details. Mercury, closest to the Sun, completes an orbit in roughly 88 Earth days, moving swiftly along a path baked by intense sunlight. Venus is almost Earth's twin in size, but wrapped in dense clouds that trap heat so effectively its surface stays at roughly 460 degrees Celsius day and night. Mars, smaller and colder, hosts the largest known volcano in the solar system, Olympus Mons, rising roughly 22 kilometers above its surroundings. Farther out, Jupiter and Saturn hold vast systems of moons, some with icy crusts that may conceal global oceans beneath. These planets take many Earth years to complete a single circuit around the Sun. Beyond them, Uranus rolls along on its side, and Neptune circles in the dim outskirts where sunlight is faint and bluish. Each orbit is a steady rhythm, traced over and over again, while the entire planetary family drifts together around the galaxy. The giant planets' moons form miniature systems of their own, with calm, repeating motions. Around Jupiter, the 4 largest moons discovered by Galileo trace orbits that can be predicted centuries in advance. Io, closest, is tugged by gravity so strongly that its interior flexes and heats, feeding hundreds of active volcanoes. Europa seems coated in a smooth shell of ice, crisscrossed by long, dark lines with indications of a deep global ocean beneath. Saturn's moon Titan carries thick, hazy air and rivers, and lakes of liquid hydrocarbons on its surface, chilled under a gentle orange glow. Enceladus, much smaller, sends out plumes of water vapor from fractures near its south pole, feeding material into one of Saturn's rings. Tiny irregular moons tumble on tilted or elongated paths, slowly reshaping the ring systems and faint dust arcs around their planets. These moons tug on one another, lock into resonances, and trade angular momentum, keeping their dance stable over countless millions of orbits. The rings around Saturn, and the more subtle rings around Jupiter, Uranus, and Neptune, are made of countless small pieces of ice and rock. Many are roughly pebble-sized, some as large as boulders, all circling in extremely thin, flat layers. In some places, the ring material may be only tens of meters thick compared to its hundreds of thousands of kilometers of width. Gaps within the rings are often carved and maintained by small moons called shepherds, whose gravity nudges particles into narrow bands. Sunlight glints off the icy surfaces, turning the rings into pale, luminous arcs when seen from a distance. Beyond Neptune's orbit, a broad region of icy bodies called the Kuiper Belt slowly orbits the Sun, including Pluto and other dwarf planets. Even farther, there may be a roughly spherical cloud of comets, the Oort cloud, extending almost halfway to the nearest stars. Here, frozen objects spend most of their existence drifting in darkness, disturbed only occasionally by distant gravitational nudges. On the largest scales, space and time blend into a smooth fabric described by general relativity. Massive objects curve this fabric, and paths of light and matter bend gently around that curvature. A beam of light skimming past a galaxy cluster can be deflected, creating multiple images of a single distant galaxy, or stretched into long, faint arcs called gravitational lenses. As the universe has expanded over billions of years, light from faraway galaxies has been stretched to longer, redder wavelengths, carrying information about the ancient past. When telescopes capture this faint light, they record events that may have happened billions of years ago, so each image is also a look back in time. Even at human scales, time passes slightly differently at different altitudes and speeds, effects so small they must be corrected for satellites and navigation systems to work accurately. In this way, every quiet moment under the night sky is gently connected to this broader, slowly evolving universe, where time itself flows at subtly different rates from place to place. As thoughts drift further from the nearness of time, attention can turn to the universe as a place filled with very soft sounds that rarely reach human ears. In the thin gas between stars, atoms collide so rarely that a single note would take years to form, but instruments can translate their motions into faint, wavering tones. Closer to home, the solar wind flowing past Earth shapes the planet's magnetic field into slow vibrations, turning charged particles into a kind of distant chorus that satellites quietly record. Around Saturn, radio waves from its auroras rise and fall like a drawn-out song, stretched across hours instead of seconds. Even black holes, which allow no light to escape, reveal their presence through ripples in spacetime when they merge, sending out gravitational waves that pass through Earth so gently that only the most sensitive detectors notice. The universe is mostly silence, but within that silence lie these rare, patient murmurs, spread across distances so large that every whisper seems to last forever.